Hello learners. Today, we shall discuss the fascinating world of solids, specifically crystalline and non-crystalline solids. Crystalline solid. Imagine a perfectly organized and structured solid. That's precisely what a crystalline solid is about. In crystalline solids, the atoms or molecules are arranged in a highly ordered repeating pattern called a crystal lattice. This arrangement extends in all three dimensions, creating a uniform and symmetrical structure. Due to this well-defined arrangement, crystalline solids possess distinct geometric shapes and angles, forming beautiful crystals. Properties of crystalline solid. First, geometric properties. The atoms or molecules in a crystalline solid are arranged in a three-dimensional lattice, forming distinct shapes and faces. This results in a well-defined and symmetrical structure, enabling scientists to determine the crystal structure using techniques like X-ray crystallography. Second, melting point. Crystalline solids tend to have specific and sharp melting point due to the uniformity of their lattice structure. When heated, the thermal energy overcomes the forces holding the atoms or molecules in place, causing the lattice to break and the solid to transition to a liquid state. Third, anisotropy. Crystalline solids often exhibit anisotropic behavior, meaning their properties vary with direction. This arises from the different atomic arrangement along different crystallographic axes. Let us take example of crystalline solid showing in the following figure. Crystal structure of sodium chloride. Now, let's shift our focus to crystalline solid. The solids in which the particles are not arranged in any specific order, or the solids that lack the overall order of a crystal lattice, are called amorphous solids. Properties of non-crystalline solid. First, melting point. Instead of a sharp melting point, they tend to soften gradually over a range of temperatures. They do not undergo a distinct phase transition from solid to liquid. Second, lack of long-range order. Non-crystalline solids do not exhibit a repeating pattern throughout their structure. The arrangement of atoms or molecules lacks periodicity, making it difficult to determine a specific crystal structure. Third, isotropy. Non-crystalline solids are isotropic, meaning their properties consistent regardless of the direction in which they are measured. Since there is no preferred, such as mechanical strength and electrical conductivity, are uniform in all direction. Let's us take an example of non-crystalline solid. Amorphous solids are glass, plastic, and gel. I hope these class will be beneficial for you. See you again in other videos. Thank you.